you will have to notice and understand that the direction of b cap is same as that of b vector, because we have just divided it by a number and we did nothing else. Now from the theory that we studied just now about the direction cosine, if you think from that point of view, direction cosine of b cap is the same as that of b vector. If you find the cos alpha, if you find L for b vector, it would be 12 upon 13 root 2. If we find the direction cosine for b cap, L, then the x component is 12 upon 13 root 2 upon the magnitude. The magnitude is 1. So if you see, the direction cosine are the same. If the direction cosine, and similarly you can do for m and n, they will also come out as same. So if the direction cosine is same, that means if this is b vector, it has particular angle with x, y and z axes, then b cap also have same angle with x, y and z axes. That means it is pointing in the same direction. It is located similar, actually the same with respect to the axes, with respect to the direction. So the direction of b cap is same as b vector. We can see from the direction cosine. So b cap is actually in the direction of b vector, having magnitude 1. What we were asked to find a vector parallel to b vector having magnitude of that of a vector. A vector has a magnitude of 5 root 2. So what we have been asked is to find a vector of magnitude 5 root 2 parallel to b vector. What we have found is a vector parallel to b vector with magnitude 1. We have to make the magnitude 5 root 2. We have to simply multiply this by 5 root 2. So the c vector that we are looking for is 5 upon 13, 12 I cap plus 13 j cap plus 5 k cap. That's it. This is conceptually important because what we have done here, we have to do the same thing over and over again in lot many problems that are to come later in the course. Okay, let's solve another easy one, oral problem. No pen, no paper. Suppose we have a vector like 6 I cap plus 2 root 3 j cap plus z k cap. Now the given information is L is equal to half. Then find the value of z, or find the value of z such that L will be equal to half. What is L? You know? Good. If you know, then find the value of z if L is equal to half. So it's an oral problem, and I hope you're not using pen and paper and debilitating your own chances of excelling. Fine, it shouldn't be a problem for you to find z is equal to 4. I hope you have found out. Congratulations if you have. And you have. Okay, question number 7. Question number 7. Suppose a vector is given as 3 I cap minus 2j cap plus k cap, and a vector b is given as I cap minus 3j cap plus 5k cap, and a vector c, suppose, is given as 2 I cap plus j cap minus 4k cap. Now the question is, these three vectors form sides of a triangle. If at all they form sides of a triangle, then that triangle would be option number 1, equilateral triangle, option number 2, isosceles triangle, option number 3, right angled triangle. Option number D, they form no triangle. It's a good problem. Think about it and do it. So basically, from your past experience of class 8, 9, 10, you have done these kind of problems before in your coordinate geometry. So you know what to do. Actually what you have to do is you have to basically find the length, the magnitude of these vectors. If you find the magnitude of vector A, it will come out as root 14. If you find the magnitude of vector B, it will come out as root 35. If you find out the magnitude of vector C, it will come out as root 21. And you see that are they going to form equilateral triangle by any chance? No. Are they going to form isosceles triangle? No. Can they form right angle triangle? Oh, they are Pythagoras triplets. The square of this plus square of this is equal to square of this. So Pythagoras triplets. So they are going to form a right angle triangle. So you can mark option C as the right answer, and you will get required full marks. Okay? Okay. Now if you say okay, that's not okay here, because conceptually you are wrong. The option C is right, but you have to check for other things. If you did just what I said and you just calculated the magnitude and you just checked that they are Pythagoras triplets and you just take the answer C, you are lucky actually. You got the right answer by chance. But see, suppose if there's a right angle triangle like this. This is a right angle triangle. Okay, now they do their length, if their length form Pythagoras triplets, it's fine, but in 3D the orientation could be like this and they never form a triangle, but the length are Pythagoras triplets. Suppose they are 3, 4 and 5, or they are root 14, root 35, root 21, but they may not form a closed polygon at all. They may not form a triangle. The orientation could be like this, and if you just check for Pythagoras triplets, then actually they are going to be a Pythagoras triplets, but their orientation, the orientation of the vectors would be such that they will not form a closed triangle. They will not form a triangle at all. They could be oriented in space like this, or like this, or like they could have any sort of orientation, and they will not form a closed polygon at all. So just to check that they are Pythagoras triplet is not okay. What you have to do is, if you know the position vector, if the vector A is 3i cap minus 2j cap plus k cap, you know the position vector of the tip. The tip is 3 minus 2, 1. Then the difference, if you find a vector, and we have seen that before how to find, if you know the position vector of this point, if you know the position vector of this point, then the position vector of this minus position of vector of this will give you a vector originating from this point to this point. Now if the position vector, if you check for these two vectors, and if you find the displacement vector from the tip of one to the other, that results in the third given vector, then they are oriented in proper orientation to complete the sides of triangle. If not, then not. Just check the position vector for A is 3 minus 2 1, for B is 1 minus 3 5. Now if you subtract B from A, you will get 2 1 minus 4, which is the position vector of vector C. Now if you did it for A and B, you got C. You do it for B and Z, you will get A, and you do it for A and Z, you will get B. So if you do that, then that is the proof then that they are actually head to head and tail to tail, and they are forming a closed loop, they are forming a triangle. So you have to check for both actually. So the vectors, I could have given some other vector whose magnitude still would have been, instead of minus 4, if I make it plus 4, the magnitude of this still would have been root 35, and still they would have been Pythagoras triplets. Now the magnitude of this still would have been root 21, and they still would have been Pythagoras triplets, but the orientation in space would be such that they would not form a triangle. In that case, the answer would have been D. So you just have to check